Welcome to the VI technology booth here at SMTAi. I'm joined by Max Fabiano, who's the US sales manager for VI technology. Welcome, Max.
Hello.
Okay. So we're standing here in front of your basically a monitor that's showing your software suite, the Sigma software suite. But we have a new component which is called the Sigma line, which essentially joins your SPI with your post-reflow AOI.
That's correct.
Yeah. Can you explain a little bit to us about what it is you're doing here?
Yeah, so traditionally VI Technology has developed a line of inspection products that allow us to do paste inspection and pre or post-reflow component inspection. And where the rubber meets the road today is what do you do with all this data that you collect at, again, basically the beginning of the line and the end of the line, and how you correlate this data together. So we've been working over the past few years on a software suite called SigmaLink, and SigmaLink allows us to do different things in terms of programming both machines at the same time, collecting data from both systems and looking at it and be able to analyze and understand where the issues are in the manufacturing process. But the latest thing about this is the development of a module called SigmaLine. Traditionally, you can review defects at the AOI and you can see what components the AOI has identified, whether it's a solder joint, lift and lead, or issues basically at the component stage. What we're doing now is we're trying to link that information with what happened at SPI. So if you had, let's say your tolerance at SPI set at 50% and SPI says it's 51%, what do, right? Well, most likely you would say, it's good enough, let it go. The question is, what happens at the end of the day, right? Does that affect your process or not? So what we did here is basically develop a software tool that allows us to review both sides at the same time. So when that board gets to AOI and it shows you a failing component, you can now see what they look like when it was first, what their location was first printed. Right. And if you made the decision to allow that deposit to pass your printing process, well, how did that affect, again, how did that come out at the end of the line, at the end of the oven? Right. The innovation here is not so much that the board stops if AOI fails it. The innovation is also in the fact that this will stop even if AOI doesn't fail that component. Right. So let's say that you had an event at SPI, that event can be it actually failed and you decided to let it go, or maybe you had a warning which it's allowed to, you typically go through the process. Mm-hmm. Then that board gets to AOI and that actually passes AOI. It wouldn't stop, right, because it's passing the inspection. So as you can see here, the green border indicates that this inspection passed the AOI test, but the orange border indicates that it failed or has a warning at SPI. So now the operator can actually review this and make a determination as to whether the decision at SPI had an effect at AOI or not. And of course, this becomes more meaningful as the pin count goes up and components get more complicated and so on. And so if the determination is then that there was actually a cause at AOI, the operator, by having the operator sanction a defect here, that will change the sanctioning in the database. And so then quality...
But not in the software.
But not in the software. So we don't want to be changing programs and tolerances just by doing this, but we want to be able to flag a programmer or a quality manager to go and look at the data and say, do I need to change my tolerances? Do I need to fine-tune my programs? Or do I just need to retrain my operators? Or do I have an issue with the process somewhere else that, it's outside of my control?
So I think the starting point here, though, is that you're using true metrology across both your SPI and your AOI, so you're able to give real data back and forward.
Right, yeah, so they're true metrology tools, as you said. They're measurement-based tools, volumetric, full volumetric, full 3D for AOI as well, and so we have actual data.
Mm-hmm. That's great. So it's great. I like the idea where you can come in with SPI, if it gets flags a warning, then basically that warning will come up again at AOI, so you can get a double check really to make sure, just to verify that it did actually pass correctly.
Right. The nice thing about this is that a lot of people don't realize is that there is a lot of technology behind all this, right? It sounds easy to make it stop and so on, but if you think about it, we have to save all the images from SPI and save all the images from AOI temporarily, of course, because we may want to prune that later on so that we're not storing terabytes worth of data. and we have to have the communication between the SPI and AOI, so that's possible by having our pieces of equipment in the line, and so that allows us to do that.
Are there any elements of self-learning in this AI?
I'm not sure what you mean.
Well, I mean, the system picks up defects at SPI, flags them again at AOI. Does the system learn as it goes along, or does it, or is it just a simple? Yes, it flagged up for a warning here at SPI, therefore it's definitely going to flag up, and that's it.
Right. So each system is designed to methodically give you the right answer every time. What I mean is that it's based on tolerances that are set, explicit tolerances that are set for every failure category. Right. So there is no learning from that standpoint. The learning portion, we are kind of developing that as a feature aspect of this, sort of an intelligence behind all this that will allow you to give you a best guess as to where the problem might be in your process. So we're trying to eliminate the false calls and the escapes, and so that you're only dealing with real hard facts and data of where the problems are, and then by having statistical tools and kind of a running history of where the defects might be and how they will resolve perhaps, we're working at kind of developing that framework.
Great, so that's the Sigma line. It's a very interesting piece of software, and congratulations and thank you for showing us through it today.
Okay, thank you very much, appreciate it.